Good day, sir. This is Group 2 and our topic is all about describe the difference principle in ship handling, explain the significance of deadweight, draft, trims, speed under keel, clearance, turning circles, and stopping distance in ship handling. I am the first reporter, the Cadet Degamo, with my members, Det Cadet CUBAR, Det Cadet DAUS, Det Cadet DAYANAN, Det Cadet Leon, Det Cadet DEMECILLO, Det Cadet ESCALA, Det Cadet ESTRADA, Det Cadet GETALADO, and Det Cadet HURAN. So, principles of ship handling. Ship handling and maneuvering is defined as art of proper control of a ship while underway, especially in harbor, around docks and piers. It is one of the skills that any ship handler finds very satisfying when well accomplished. Next is the three basic ship motion. First is the longitudinal motion, or known as forward or astern. Second is lateral motion, or what we call sideways. Third is rotational or turning motion. Vessel also have other behaviors worth noting when her maneuvering equipment is in operation. Depending on the types of propeller, a ship with a single propeller when run ahead from stop cants to either port or starboard. When to put a stern from stop to stern cants at a fast rate to port or starboard. When a ship has headway and the rudder is put over to 1.
Factors and forces that commonly constitute a change in a vessel's behavior while being maneuvering. External factors/forces. Tide, a sudden change in wind velocity and direction. Sit and drift, the proximity of other vessels. The depth of harbors. Effects of external forces. The effects of external forces may become advantageous or disadvantageous to the ship handler. It is the best that these effects are foreseen beforehand so that necessary steps to counter or make use of them during the maneuver are made. As some experts put it, the art of ship handling involves the same effective use of the forces under the control to overcome the effects of external forces. Internal factors, forces under control of ship handler. First, engine power. Second, speed. Third, effects of the type of propeller. Fourth, rudder movement and type. Fifth, thrusters. Sixth, anchors and mooring lines. And seventh, tugboats.
The set, drift, and the drift angle can be estimated graphically or by mathematical calculation. This drift angle is applied opposite to the set of the current in order that the ship will progress along the intended course line. The factors affecting the drift angle depends on the load conditions of the ship, the speed of the ship, the velocity of the wind or the rate of the current and their direction relative to the ship fore and aft line. Then there is also the effect to the ship's speed if the wind or current is ahead or stern. Other variables factors affecting ship's handling. First is human factor. A delay in time between your given order and the execution of the order will affect how you intend to move your ship. This cause is caused by human factors because the individuals you are ordering may have different response depending on their training and ability to perform the job, or the orders have been relayed by an officer to the helmsman, which is a bad practice that should be avoided so that the coming officer should be able to give his orders directly to the helmsman. Second is sudden breakdown or failure of the ship's equipment. Third is mode of communication failure from the bridge to the engine room or vice versa, or the fore and aft station. Fourth is language problem between nationalities. And lastly is the ship's momentum.
The deadweight. the difference between the displacement and a mass of empty vessel or lightweight at any given draught. It is a measure of ship's ability to carry various items like cargo, stores, ballast water, provisions, and crew, or etc. The next,
Drafts are used to determine the weight of the bulk cargo such as iron ore, coal, steel scrap, grain, and some specific quantities of liquid cargo loaded onto or discharged from a vessel. In principle, draft service required only a measurement of the water displacement by the vessel before and after the cargo is transferred. Along with a measurement of the water density, water displacement is measured through draft marks on the ship and converted to volume using draft tables. The weight of displacement water is calculated by multiplying its volume displacement by its density. The difference between the weight of the water displaced before and after the cargo transferred will equal the weight of the cargo within measurement accuracy limits.
Trim and loading. On a general cargo ship or tanker, the difference between the turning qualities when lightly laden and when fully laden is very marked. When a deeply laden cargo ship has much larger turning circle than when the lightly laden, and she is more sluggish and answering her rudder. Trim by stern usually increased by tactical diameter but helps ship to keep her course more easily when on a steady course. When trimmed by the bows, her turning circle is likely to be decreased. She does not answer her wheel to readily as usual, and once she has started to swing, it is more difficult to check her. The effects of trimming is to move the ship pivoting point towards the deeper ends.
So next is speed. The effect of speed on tactical diameter will vary from one type of ship to another. Often, higher speed may lead to a greater tactical diameter because of the rudder may stall. Modern rudders on smaller ships, however, are able to operate satisfactorily at higher water speeds and greater angles, and hence the tactical diameter may not vary much with speed. Ended, on some ships, there is a best speed giving the minimum tactical diameter at a higher or lower speeds. The tactical diameter is greater. Watchkeeping officers should be fully aware of the effect of speed on the turning qualities of their ship.
Underkill clearance. Underkill clearance, in simple terms, underkill clearance is the vertical distance between the bottom of the ship and the seabed. As the seabed is complex surface that is likely to differ in depth at all points across the ship hull, that clearance shall be sufficient to allow ships floatability in most unfavorable weather conditions. Maintaining the vertical distance between the ship hull and the ocean floor keeps the keel free of the seabed and reduces the chances of running around. Turning circle. When a vessel is made turn under a continuous helm through 360 degrees, it will follow roughly circular track called turning circle. Advance. It is the distance traveled by ships along original course line when she alter course through 360 degrees.
Stopping distance in ship handling. Stopping distance is the distance covered by a ship after the engines are stopped. There are two types of stopping distance. First is the inertia stop. It happens when the engines of the ship is stopped, but the ship will still continue moving in the same direction for some more distance due to inertia. Here, no astern command is given, and hence, ship will travel more distance in the inertia stop method. The second one is crash stop. Here, the engine, which is moving in a head direction, is given an order for full astern. leaving the rudder in a midship position to stop the ship within minimum distance and shortest possible time.
Turning circles and stopping distance in ship handling. A turning circles the radius of the circle about which a vessel turns when steered. The advance of a ship for a given alteration of course is the distance that her compass platform moves in the direction of her original line of advance, measured from the point where the rudder is put over. Stopping distance is the distance which a ship will continue to move after action is taken to stop engine until the ship comes to rest. The transfer of ship for a given alteration of course is the distance that her compass platforms moves at right angles to her original line of advance, measured from the point where the rudder is put over. The ship handler, for instance, should be aware of how long it will take for a vessel to become stopped in the water from a full ahead position or how far the vessel will advance in a turn.
You are a summer and after all I'll keep